So in this Unit 7 test review, we're going to solve, graph, and describe radical functions. So let's go over number 1. So it says solve for x, find all the solutions. So first thing we want to do here is subtract the 21 because we want to get the radical on one side of the equation by itself first, okay? So then we're going to end up with 5 minus 4x equals x. Then, if you recall, we're going to get rid of this radical by squaring it, which means we have to also square the other side. So that gives us 5 minus 4x equals x squared. From this point forward, we need to move everything to one side of the equal sign. So we're going to subtract the 5, and we're going to add the 4x to both sides. So that's going to give us 0 over here. Our next step would be to factor. So that's what we're going to do. We're going to factor this x squared plus 4x minus 5. And to do that, we're looking for the factors of negative 5 that add up to be 4. So that would be plus 5 and minus 1. Then we're going to set each of these factors equal to 0. So x is equal to negative 5 here, and x is equal to 1 here. Now recall that when we're doing this, we have to check these answers, because if we don't check them and we assume they're both correct, we may be wrong. One of them may be an extraneous solution. So what we're going to do is we're going to take both of these and we're going to plug them back up in the original equation. The only thing is I'm going to start here, guys, because that 21 cancels itself out on both sides. So I'm going to do the square root of 5 minus 4x equals x. So I'm just going to plug in that negative 5. So that's going to be 5 minus 4 times a minus is equal to minus 5. So this is going to give me the square root of 5. And that's going to be plus 20 because minus 4 times minus 5 is 20. So this is going to be the square root of 25, which, again, setting that equal to, so this could be 5. 5 does not equal negative 5, y'all. So this is an extraneous solution. Okay. Now let's plug in that 1, and let's see how it does. So we've got 5 minus 4 times 1. Does that equal 1? So here again we've got 5 minus 4. And so that's going to be 1. Whoops. So yes, 1 equals 1. So that is our actual solution right there. That's the valid solution. The x equals negative 5 is an extraneous solution, so it is not the solution. Creates a false statement. So number 2, here again, I'm going to rewrite the equation first. 28 minus 3x equals x. So this time we're going to square both sides again to get rid of the square root. So it's going to give us 28 minus 3x equals x squared. Our next step would be again to move everything to one side of the equal sign. So we're going to subtract the 28, and we're going to add the 3x. So plus 3x minus 28. So that's going to give us, these cross out obviously, so we get 0 over here. So this is x squared plus 3x. Minus 28. So again, we're going to factor this. So we're looking for the factors of negative 28 that add up to be positive 3. We know one's going to be positive, one's going to be negative. So if you think about your factors of 28, it would be 7 and 4. Here again, we're going to set these equal to 0. So x is equal to negative 7 here, and x is equal to 4 here. Once again, we got to check these answers, okay? So we're going to plug them back up in that original equation. So we've got 28 minus 3 times minus 7. We're going to see, does that equal minus 7? So this is going to be 28, and that's going to be a plus 21, because the negative times the negative is a positive. So this is going to be the square root of 49. So 7, again, does not equal negative 7. So this one's going to be our extraneous solution. Now let's check the other one. So again, over here, we're going to do 28 minus 3 times 4. We want to see, does that equal 4? So this is going to be 28 minus 12. So that's going to be the square root of 16, and that is 4. So 4 does equal 4 here. So again, this is our valid solution. The next one, first thing I'm going to do with this one is I'm going to add 6 to both sides. Okay, so that's going to give me 7 minus x equals 6. Then we're going to square both sides again to get rid of the square root. So that gives me 7 minus x equals 36. Then we're going to subtract 7. So minus x equals 29. And then you can either multiply by -1 or divide by -1. I'm going to go ahead and divide. So our x is equal to -29. And here again, we need to check it. Don't think just because you only got one answer, you don't have to check it. You still should check it. So we got 7 minus a minus 29 minus 6 equals 0. So this is going to be 7 plus 29. So that's going to be the square root of 36 minus 6 equals 0. So this is 6 minus 6 equals 0. So 0 does equal 0. So that is, excuse me, a valid solution right there. So on this next problem, we're going to subtract 26 first. So that's going to give us the square root of 7x equals -14. Then we're going to square both sides again to get rid of the square root. So that's going to give us 7x equals 196. Then we're going to divide both sides by 7 here. X is equal to 28. So once again, we need to plug that 28 back in to check and see if it's a valid solution. So we're going to do the square root of 7 times 28 plus 26 equals 12. So this is going to be the square root of 196 plus 26 equals 12. That's 14 plus 26. So this is 40. Well, that absolutely does not equal 12. So what is the answer here? There is no solution here, okay? So, as you're going to see in the first five questions we're going to do here, there's going to be 4 different types of answers. The first 2 had one extraneous solution and one valid solution. Number 3 had one valid solution, and number 4 has no solution. So now we're going to do one more, number 5. And on this one, again, I'm going to add x to both sides because I want to get that radical by itself. So x is equal to the square root of 10x. Then I'm going to, again, square both sides. So x squared equals 10x. Then we're going to subtract the 10x from both sides. So that's going to give us x squared minus 10x equals 0. Now we're going to factor. So we're getting x that's a factor of both. So that's going to be x minus 10 equals 0. So what we want to do with both of these is set them equal to 0. So we're going to have x is equal to 0 and x minus 10 equals 0. So this is going to be x is equal to 10. Now we want to check both of these solutions. So that's what we're going to do over here. So 0 is equal to the square root of 10 times 0 minus 0. So 0 is equal to the square root of 0 minus 0. So 0 is equal to 0 minus 0. So obviously 0 is equal to 0 here. So that worked for the first one. So that is a valid solution. Now we're going to check the other one. 0 is equal to the square root of 10 times 10 minus 10. So this is going to be 0 is equal to the square root of 100 minus 10. So 0 is equal to 10. The square root of 10, 100 is 10 minus 10, which again is 0 is equal to 0. So here both solutions work. Now what I want to show you guys is how you can check these solutions with Desmos, okay? So with Desmos.com, what we're going to do is we're going to put the square root, for number 1, the square root of 5 minus 4x as one equation, and then we're going to put the x as the other, and we're going to see how they intersect. So up here, we're going to do, I'm going to click down here and go to the square root And we're going to do 5 minus 4x. And that one ahead and graph that one. And now we're going to graph x here as well. So notice we have a red graph, this one up here, and the blue graph. And what we're looking for is the intersection of these two graphs, guys. That's what we're looking for. So if you recall, when we did this problem, we got two solutions, x equals -5 and x equals 1. Well, if we look over here at -5, there is no intersection of the graphs. But over here, where x equals 1, we do see the intersection of the graphs. So that's one of the ways that we can know what the solution is, especially when we have two solutions, okay? So now we're going to look at number 2. So we're going to do the same thing with it. We're going to go ahead and put the equation in on the left. So we got the square root of 28. Oops. Minus 3x. And then for the other equation, we have just x again. So here again, we had two solutions, -7. Obviously over here at -7, we're not going to see an intersection. And then the other solution we had was at 4. And indeed, you can see that the two graphs intersect at 4. All right, now let's look at number 3. So with number 3, again, we have the square root of 7 minus x. And this is a great way to just check your answers, guys, okay? And then the other equation was, we're going to move that 6 to the other side, so we're just going to say that y equals 6. Okay, so you should be able to see y is equal to 6 up here, it's red. And then we have our black graph here, which is the square root of 7 minus x. Now, what we got for our answer was -29. So we can scroll over here. Notice I'm just picking this up and moving it. And yeah, that looks like it's about at -29, right? Yep, it is. See that? So that's where the two graphs intersect at the x value of -29. All right, now let's look at number 4. So on this one, we had the square root of 7x. And again, I'm always going to do these so that I get, I'm going to actually subtract that 26, so I just have the square root of 7x on the left, and that would have given me -14 over here on the right. So y is equal to -14. And I'm going to close this out. Notice we can't see anything right now, so I'm going to actually, whoa. Hang on just a second, I don't know what just happened. Okay. So I'm going to scroll out, y'all, and I'm going to move back over here to where, okay, so you can pretty much see here, because this graph goes, starts at 0, 0, and goes up and to the right, that there's no way it's ever going to intersect this graph down here, y equals -14. So this has no solution because the graphs don't intersect. Now let's look at number 5. So on number 5, we had y is equal to 0, so put that in first. And then down here, we're going to put the square root of 10x. Be careful when you're doing this. Make sure you click outside of that radical so that you can say minus x, because you don't want that underneath the radical. So now in this one, hopefully you can see that purple line right there. Let me zoom in a little bit. You guys can see it a little bit better. So can you guys see that that's purple right there? That is our y is equal to 0. And then we have this black graph here of the square root of 10x minus x. So if you notice here again, what we got was 0 as one of our answers, and we got 10 as our other answer. And those are both can be seen here on the graph as with the intersection of this purple line right there and that black line. So once again, this shows us that the answers that we got were correct. So now we're going to do this cube root problem. Okay, so here again, the first thing I'm going to do is I'm going to add that 2 radical 3 square root of 3x minus 1 to both sides, because I'm going to get it over here. So it's going to be plus 2 cube root of x minus 1. Sorry, I can't talk today. So this is where we're at then with this one is 3. The cube root of x plus 6 is equal to 2 cube root of x minus 1. So now what we're going to do is we're going to cube both sides. Now, the key to this problem is over here on the left is pretty easy because those two things cancel each other out and we're just left with x plus 6. But over here we have to apply this cube to both parts of this. So this is going to be 2 to the third and then x minus 1. So this is going to be x plus 6 is equal to 8 times x minus 1. So this is going to be x plus 6 and then 8x minus 8. Now I'm going to subtract the x from over here and I'm going to add the 8 to both sides. So that's going to give me 14 is equal to 7x. And then we're going to divide both sides by 7. So x is equal to 2. Now if you recall when we taught this, we told you that there are no extraneous solutions with cube roots, but I'm still going to plug this back up in and check it because I don't like getting stuff wrong. So I'm going to go ahead and I'm going to do it at this step right here, guys, so I can see if they are equal, okay? So I'm going to do the cube root of 2 plus 6, and I want to see is that equal to 2 times the cube root of 2 minus 1. Well, this is going to be the cube root of 8, and this is going to be 2 times the cube root of 1, right? So if you guys remember, this is how you put that in the calculator, right? 8 to the 1/3, and that's 2. And then this is going to be 2 to the 1 to the 1/3, which just so happens to be 1. So this is going to be 2 times 1. So 2 does equal 2. So that does check out as our solution. And the best way to do that, again, is to plug it back in. All right, so our number 7, we're going to... On this one, we're going to go ahead and cube both sides because we're trying to get rid of that cube root again. So that's going to give us 5x here minus 4x squared is equal to x cubed. We're going to, again, move everything to one side of the equal sign. So we're going to subtract that 5x and add the 4x squared. So plus 4x squared over here and minus 5x. So that gives us 0 over here because those cancel each other out. And we get x cubed plus 4x squared minus 5x. So hopefully you guys can see, because we need to factor this thing, that there's an x in every term. So we're going to factor that out first. That's going to give us x squared plus 4x minus 5. Now we need to factor what's in those parentheses some more. So we're going to put x times x because that's x squared. What are the factors of negative 5 that when added together give you a positive 4? That would be plus 5 and minus 1. So now the key with this is we're going to set all three of these factors equal to 0. So we're going to say x is equal to 0, x plus 5 is equal to 0, and x minus 1 is equal to 0. So our three factors are x is equal to 0, x is equal to negative 5, and x is equal to positive 1. Those are our three answers. And again, that makes sense because a cube would have up to 3 places where it would cross the x-axis, okay? All right, so number 8, this is a word problem. It says the height of a free-falling object is given by h is equal to v squared over 2g, where h is height in meters, v is velocity, g is acceleration due to gravity in meters per second squared, and h is the distance in meters that the object is falling. The value of g depends on which body / planet, if an object. So basically, gravity depends on the planet, right, and the thing that's being dropped. If an object on the moon falls from the height of 13.85 meters, where the gravity is 1.57 meters I can't talk today, y'all. S squared. We'll just leave it at that. And the velocity, what would the velocity of the object be on the surface of the moon? So we're just going to fill in. So h is equal to 31.85, and gravity is going to be 1.57. So what we're going to do is plug those into the formula. So we've got 31.85 is equal to v squared over 1.57. Oh, 2 times 1.57. Sorry, I almost missed that. All right, so let's just go ahead and multiply that 2 times the 1.57. And when we do that, we get 3.14. So this is going to be 31.85 is equal to v squared over 3.14. Now to get rid of that 3.14, don't we need to multiply both sides by 3.14? So that's what we're going to do. So that's going to give us 100.004, something like that. So basically, essentially 100 y'all. And that's equal to v squared. So how do we get rid of the v squared? We take the square root, right? So we're going to take the square root of both sides here. And we're going to see that v is equal to basically 10. And these are 10 meters, okay? All right, let's do our next word problem. This one says the formula for finding the mass of a metal cube as it relates to its side length is s, and its density d is m equals s cubed d. If a gold metal cube has a mass of 1,200 grams, so we're going to say m equals 1,200, and the density of the gold is 19.3, find the side length in centimeters to the nearest centimeter. Okay, so on this one, we're going to actually fill in this formula exactly like we got here. So that's 1,200 equals s cubed times the density, which is 19.3. So this time, aren't we going to divide both sides by 19.3? We need to get that s by itself. So that's what we're going to do. So when we do that, I got 62.18. And that equals s cubed, right? So how do we get rid of a cube? Don't we take the cube root? So, and again, remember that when we're doing this in the calculator, we're actually going to do 62.18 to the what? The 1/3 power, okay? So when we do that, it equals 4 centimeters. So we're just going to round it to 4. So number 10 says that the parent function f of x equals the cube root of x, and it's translated 3 down, stretched horizontally by a factor of 4, translated 5 left, and reflected across the y-axis. What is the transformed function? So the first thing I want to show you guys is this parent function with the transformations. So if we've got f of x is equal to a is out front, that would be vertical stretch or compression. B is horizontal stretch or compression. X minus h, that is going to be left or right, and then plus k, that's going to be up or down. Okay, so it says that the parent function cube root of x translated down 3. So that's going to be minus 3 over here. So minus 3 down 3, because that's up or down k, right? Stretched horizontally by a factor of 4. So when we're dealing with this, we're going to talk about, remember this is opposite in here, so that means I'm going to have 1/4 here because it was stretched horizontally. And then it's translated left and reflected across the y-axis. So it's translated left, so if it's left, it's minus a minus 5. So this is where we always said it was plus, right? And then it says it's reflected across the y-axis. Well, if it's reflected across the y-axis, remember that's going to be negative under there. B is going to be negative if it's reflected across the y-axis, and A is going to be negative if it's reflected across the x-axis. So that's my f of x. So let's go ahead and simplify this a little more. So f of x is equal to the square root of minus 1/4 x plus 5 minus 3. Okay? All right, let's look at the next one. So this one says that the parent function f of x equals the square root of x is translated to right. So here again, I'm going to put this in the radical, and that's going to be x minus 2, because it's going right, which would be a positive number. Compressed vertically by a factor of 1/3. So this would be out here, compressed vertically, and translated up 1. And then reflected across the x-axis. Remember, if A is negative, then that is a reflection across the x-axis, okay? So that is the function with all of those transformations. This one says, what is the domain and range of the square root graph below? Well, the first thing I want you guys to realize is that arrow that goes over there, okay? This was the starting point of the graph, and that's at where? 7, comma 2. And that's important for us to recognize because we're going to use that when we're talking about the domain and range. So the domain is going to be x is going to be less than or greater than. So is the graph moving to the right or is it moving to the left? Well, it's moving to the left, so we're going to put it less than or equal to. And what number is our x value here? Remember, this is x and this is y, so that's going to be 7, okay? Then our range, same thing, we're going to talk about y. So y, what's happening to y? Is it getting bigger or is it getting smaller? And it looks to me like it's getting smaller because it's headed towards negative infinity down here, right? Okay. So here again, y is going to be less than or equal to, and our y value was right there, and that's 2. So that's our domain and our range for this square root function in this graph. So on this one it says, what are the domain and range of the square root equation? Okay. So remember, when we're talking about domain and range, we're always going to use our h, which here is -3, and our k, which is going to be 6, okay? So on this one, we're going to say that x is, and let's go ahead and look at this graph on decimal so you guys can see which direction it's moving in. Okay, so I put this equation in my graphing calculator, and I can see that this function starts at, that's -3, 6, right? And then it's moving to the right, okay? So it's falling, but it's also, x is increasing, but y is decreasing, okay? So let's go back and look at our graph then. So if you recall, the graph was headed to the right, so that means x is going to be greater than or equal to our -3 because that was our h, and then y was getting smaller, it was going down. So we're going to say y is less than or equal to 6, okay? This is what is the zero of the function. Well, to find the zero of the function, what we're going to do is set this equation equal to 0 and solve it. So that's what we're going to do over here. So we're going to say 0 is equal to -2 square root of x plus 3 plus 6. Okay, so we're going to subtract that 6 from both sides. Okay, then we're going to divide both sides by -2. So that's going to give us 3 over here is equal to the square root of x plus 3. So now we're going to square both sides. So that's going to give us 9 equals here, x plus 3. And we're going to subtract 3 from both sides. So x is equal to 6. So that is the 0 of our function. And again, remember, the way we solve that is by setting the equation equal to 0. Then we want to go back and look at our graph and see if we can determine the end behavior. So let's go back here. So as x is approaching infinity, so x is going this direction, what's happening to our y value here? Can you guys see that it's approaching negative infinity? Okay, so we're going to go back here to our, so we're going to go, this is, so I'm going to say, as x approaches positive infinity, f of x is going to approach negative infinity. Now let's go back and look. As x approaches negative infinity, what happens to f of x? That's what we want to look at on the graph next, okay? So again, let's go back here. There. So as I'm going this direction towards negative infinity, what's happening to the graph? What is y approaching? Notice it's approaching 6 right there. So that's going to be our answer for that one. Let's go back here. So that means this is 6. Now it says find the intervals of increase and decrease. So once again, we're going to go back and look at our graph. And so hopefully you can see that this graph is going down. So there are no intervals of increase. There are only intervals of decrease. And it's decreasing from where? Notice it's decreasing from, and then we're looking at the x values now. So what value is that? From -3 to infinity, the graph is decreasing. Okay, so that's what we're going to write. So we talked about, are there any intervals of increase? No, there were no intervals of increase. So increasing is none. But then decreasing went from the -3, again, we're talking about x values here, on to infinity. That's when the graph is decreasing, is from when x is equal to -3 on to when x is infinity, okay? Now we're going to move on to the cube root function. So here again, we're going to talk about the domain and range, the zeros, the end behaviors, and the intervals, okay? So I'm going to go ahead and graph this again in Desmos. Now when I put this one in here, I'm going to actually put the equation in parentheses, and I'm going to take it to the 1/3 power because I can't do a cube root in here. So I'm going to say the -2 here. Then I'm going to put another set of parentheses, and I'm going to do the x minus 1. And then I'm going to close my parentheses, and I'm going to click to the right to get outside of there. And I'm going to take this to the 1/3 power. So I'm going to use my caret, that's Shift 6, to put it up there, and I'm going to take this to the 1/3 power. Because remember, a cube root and a 1/3 power are the same thing. And then I'm going to subtract my 4 from it, okay? So, and you can also put this in your graphing calculator if you have one. So notice here again, we want to talk about this graph, okay? So when we're talking about cube root functions, when we're talking about the domain and range, hopefully you remember that the domain and the range are all real numbers, right? So domain here is going to be all real numbers, and the range is going to be all real numbers. So it asks about the zero of the function. So here again, we're going to set this equal to 0 when we're trying to find the zero of the function. So I'm going to do it out here. 0 is equal to the cube root of -2 x minus 1. I'm trying to write too fast, y'all. X minus 1, and then the -4. So we're going to add 4 to both sides. That's going to be 4 out here. And then this is going to be -2 x minus 1. So again, this is a cube root, so we got to cube it to get rid of that cube root. So we're going to do that to both sides. So that's going to give us 64 here is equal to -2 x minus 1. So we're going to divide both sides by -2. So that's going to give us -32. So now that's equal to x minus 1. So we're going to add 1 to both sides. So x is equal to -31. And we're going to look at the graph and see if that's true. Sometimes you guys are going to have to really scroll out some to see these. Okay, so there's the graph, and you can see where it intersects right there. Yes, at -31. So that was correct. So the zero of the function is x is equal to -31. And then the end behaviors, if you recall, let's go back and look at the graph again. So as x is approaching positive infinity over here, what's happening to our y values? Well, they're going to -infinity. And as x is approaching negative infinity, what's happening to our y values? Well, they're going up and up and up. So they're going up to positive infinity. So as x approaches infinity, our f of x was approaching negative infinity. If you remember, the graph is going down to the right. And as x approaches negative infinity, that means as we're moving to the left on the graph, f of x was approaching positive infinity. Okay. Then if we're talking about intervals of increase and decrease, if you recall, the graph started high and went low to the right. So the graph had, again, no increasing. So there was none when it comes to increasing. And decreasing, it went from negative infinity all the way to infinity. It was decreasing the whole graph. Okay.